Assalamu alaikum class. Today I'm going to discuss with you the survival analysis, and before we begin I would like to present you this thing that you should focus on this image. Okay, so let's begin the lecture with one single question: why we need survival analysis? In many situations, as you know, the rate of occurrence of the event under study doesn't remain constant over time. For instance, the probability of dying may rise suddenly with the onset of a disease, but then decline gradually as the time since diagnosis increases. The most appropriate approach in this situation is to conduct survival analysis. Let me give you an example. Let's say the example of a bird flu. So most of the time when the migratory birds coming from the northern hemisphere to the southern hemisphere, they stay in Pakistan for a certain period of time in June or May. So we hear about something about the bird flu incidents. But later in the rest of the year, the incidence of H5N1 outbreaks are rarely reported. So in order to assess the occurrence of such events and the survival of an industry, it would be much better if we could say draw a survival curve for H5N1 exposure over a gradual period of months or years. Similarly, the outbreak or onset of any disease would be considered as the most prime period. Then there would be a log phase, and then would be a stationary phase, and then it will decline. So it is most vital to gauge the survival of individuals depending upon the duration or the period we are following those individuals for a certain time duration. All right, so let's move to the next thing. Now, what are the prerequisites or the estimation requirements of a survival analysis? There are three core requirements for survival. Number one, case definition. Number two, clear and well-defined starting points. Number three, clear and well-defined outcomes. Now, the starting point, as let's begin with let's deal with all of them one by one. Case definition means that the case, how you are going to register a case in your survival analysis. Is it the date of diagnosis, or is it the date of the disease onset, or is it the date the patient visited any particular hospital? In case of cancer, the date of diagnosis is usually believed as the date of onset of a disease. There are certain variables, things, but you should know about the case definition. Then the second point is clear and well-defined starting point. Is it the date of diagnosis or something else? Now, the case definition means the case has already been ascertained as defined CA breast patient, CA ovarian, CA prostate, or any particularly designated. So the diagnosis process has been completed and you are labeling that patient under a particular disease category. The second point of starting point is the induction is not basically at what stage you are inducting them for this particular survival analysis. Is it the stage of diagnosis you are taking it in, or is it the date of a visit of a hospital, or something else? Now, the clearly and well defined outcome means the death or the reoccurrence. What is the outcome mean? Like how long you are going to follow that individual, and what would be your end point, whether it is a death or relapse of a disease you are taking. So you should mention these three criteria right at the beginning. Then the starting point, there are a few more definitions over here. The starting point and the occurrence of the outcome of interest or the date of last contact is known as survival analysis. Interpretation of the result of a survival study depends upon the length of a time each person was followed. A typical survival study involves a patient accrual period during which the patients are recruited, their follow up is initiated, one phase, a follow up period during which the patients are followed up but no further recruitments are made, and a closing data for the analysis. So, this means that we are dividing the survival study based on three periods: accrual, follow-up period, and a closing date. All right. Similarly, the three requirements: case definition, starting point, and the outcome. That's good. And then we are going to assess disease-free survival or overall survival. We are talking over. Next thing, censored group. Now, it's basically, it is rare to find a closed group. What do you mean by closed group? A closed group is a group on which the number of individuals inducted at one time point and they all departed from your study at a particular time point. Consider this an example of any distance traveled by the individuals from one station to another station by train. So all the individuals you are expecting to board on at one time point, and then they depart or disembark from the train at the next station. Okay, but in reality, in medical surveys or in life, you are not expecting that all of the people should disembark from the train at a certain time point, and that's the end of a time or something like that. So there will always be certain group of individuals who are going to be lost during the follow-up. They may have changed, or they have addresses, they migrated to different places, or you lost contact to them to any reasons. So okay, so that data is called as censored group, because you are not sure about their status, whether they are alive, whether they are dead. So how you are going to calculate or interpret your results about those things? So these groups are the categories is called as censored group, and this phenomena is called censoring. And the, the, the second important thing we should keep in mind is the prefer consecutive follow-up intervals. So basically, follow-up interval means that you are not collecting a data at day one and then after 10 years you are making a follow-up analysis by telephones, by postcards, or any other thing, that what is the status of these individuals. It is always better to collect your follow-up data between different intermittent points. Sometimes they are 6 months, sometimes they are 3 months, and sometimes per year. All right. Why? Because these intermittent points are going to inform you about the censoring group position. Right. I'm going to share with you the examples in the next slides. So over here, A is a very crude way of summarizing the survival experience of a cohort, as it ignores any information about when the death or censoring took place, only the total number of deaths and the total number of censored observations during that defined interval would be happening with you. B, comparing the survival experience of different cohorts. Now these are the two distinctive points. For example, if I want to compare the survival analysis of Pakistani individuals for 5 years, follow-up study in breast cancer, and I want to compare it with, let's say, Indian breast cancer affected women's population, and over there the data is of, let's say, 5 years too. So I can have a 5 years based on comparison on based on the duration. I can compare both these studies. So a study published by Fraz over here and, let's say, Agarwal in India could be compared based on the survival analysis, that which proportion of individual women are have living a more disease free or overall survival, whether they are Pakistani, whether they are Indian. Such sort of comparisons could be made based on the survival period over a longer duration of time. But if I have summarized my study for just 1 or 2 years, it won't be possible for me to interpret my findings and compare them with the Indian population, because I have just a very limited information interpreting on a very limited scale, right? So it is always better to go for long survival durations and also collect the data in certain intermittent points. So uh, so one way of overcoming these limitations is to use a number of shorter consecutive intervals of time. So we can reverse this information by, like, in Pakistan we have 5 years follow-up of study with 1 year in information in each year. I have collected the data, and for example in India the information is of just 3 years. So I can compare my 3 years data with that 3 year data of Indian population and then interpret my findings in a more logistic way, that whether the Pakistani breast cancer affected women have any preferential growth advantage over nationality base or demographic location or age or any other thing which I am going to study. All right, so it is always better to go for consecutive follow-up intervals. So let me share with you an example over here. So this example may not be very clear to you, but this is actually what's happening over here is the patient's study number. Now the total number of study enrolled for this is 40. Now these are the ages. Now this is the stage of their cancer, date of diagnosis, date of contact of their death. A means alive, D means death, and these are the status. Now this is from cause of death is BC for breast cancer. Now the number of complete years of observations we have collected, number of days of from diagnosis to the contact or death. So this is something, this is like a register information recorded in a hospital or a cancer registry database about these informations we have been interpreted. Now let's have a look how we are going to see, or we can present it in a more simplistic form. Over here, if you can look, the information is presented in a style like this, that we can interpret these results based on year-wise pattern. For example, the number of individuals enrolled in this study in 1989, 1990, 1991, 1992, 1993, 1994, 1996 are 5. So over here it says that the patient number 1 was enrolled and in 1989, it remained alive till 1992. What happened in 1993? We are not sure because we lost this information for the subsequent years. Patient number 3 enrolled in 1989, died in the same year. All right. Patient number 5 enrolled in 1989, remained alive till 1995. Now from here, panel A is providing us an information from the start of this study till an year-wise plan. All right. Now if I want to study instead of this year-wise planning, I can interpret it from my own study, that the number of complete years since diagnosis. Now I am redistributing my data, and instead of writing those years, I am just writing that 0, 1, 2, 3, 4. So it's a numerical order. So apart from the based on diagnosis, I can say the number of completed years after diagnosis. Okay, so it's just the rephrasing of words instead of at what time point they have joined the study. For example, over here, if you look, then the patient number 25 joined the study in 1991. Okay, but here we are just presenting that it stayed with us for less than a year. Look over here. Okay, have you seen over here? So the patient number 25, so it's the duration or the number of completed years after diagnosis, how many times they have. So this is just another format of presenting the data, right? So based on this thing, they have studied this data and the number of completed years since diagnosis, that how many patients died alive once they are diagnosed with the disease. This is being interpreted over here. All right, so the total number of individuals 40. There's what you can say, their patient IDs are mentioned over here. Likewise, we have said that the patient number 31 died in less than 1 year. Patient number 3 died in less than 1 year. So it's a sort of full story which is being presented over here with a complete survival time. D stands for death, A stands for alive. Now if I look over here, the patient number 31 died within 1 year, and similarly these number of individuals died within 1 year. Now here stands number 1, let's say patient number 13. Now this patient number 13 is alive in the after completion of first year, but after completion of first year the information is being lost. We are unable to identify this number of 9, the sequential order 9, 13 individual. All right, so I'm going to repeat this slide in the next section. Yes, over here if you look closely, now let me simplify over here. So the data with censored information for the 2 years, D, number of deaths, divided by 40. 40 is the total number of individuals, minus 0.5 into 6. Why 6? These are the number of people which were alive between after 1 year, but I lost contact after the completion of 2 years. So I am multiplying it as per formula, and I'm calculating the answer is 29. Right? So I can write it down like this: 40 total start, and then number of individuals died 10, censored 6, alive 24. Okay, next slide. Let's go for another information for 3 years. If we focus, the number of loss I have calculated, I have pointed out over here as well. So let's count the number of D's first. So the D's are pointed out with the red dots over here. So the total are 14 till this point. Number of individuals alive are 17 in total, and the number of people lost contact. I was unable to reach out to the patient number 6, 40, 39, 38, 34, 11, 23. I was unable to contact them at the completion of 3rd year. So they are 9 in number. All right, so these 9 individuals from which I am unable to reach, I'm going to calculate the data with censored information for 3 years on them. This is the information. Probability of dying, death is equal to what? Divided by n is the total number of study population, minus 0.5 L is the loss I have observed. I have written it down over here for simplicity. Total number of deaths were 14, so 14 is over here, divided by 40, minus 0.5 into 9, and the percentage I am getting is 39. All right, so I have so what we can do, we can draw a tree diagram over here as well. So this is what we can write it down, like 40 individuals were at the start of the study. After 1 year, 7 deaths reported with 0 censored. All of the information was present. Then in the first year, after subtracting 40 minus 7, 33 individuals. Look at the tree. 33 individuals comes from the subtraction of 40 minus 7. Okay. Then the next point is 3 deaths were reported, 6 individuals lost in contact, and then in the next year we are subtracting 9. 6 plus 3, 9 out of 33, so we are getting a number of 24, and this 24 individuals, after the completion of this year, 4 individuals died, 3 were censored. So now this 17 comes from, how this 17 came from, we're subtracting 3 plus 4, 7 from 24, so we are getting 17 individuals were alive after this 3 years follow-up. Okay, so it's a pretty straightforward thing. You just need to focus on that we started with 40 individuals, 7 died, 0 lost contact in first 0 year, and then the first year's data reported 33, 24 in the second year, and at the end of the 3rd year 17 individuals were alive, and they were also in contact. Okay, so this is the simplest tree formation we have reported. Now let's make our life more easy, but we can make it more complicated too. So let's say we are interested to draw the probabilities, that what is the probability of individual dying in the first year of this cohort? What is the probability of individuals living for 1 year, 2 years, or 3 years? So the estimation of probabilities on a tree is calculated as number of individuals died were 7 over here in the last table. Remember, 7. And over here was 40. So if we divide 7 by 40, we are going to get the probability is 0.175. So probability of a subject dying in year 1 is written over here 0.175. Okay. Now if I subtract 1 minus 0.175, I'm going to get a value which is 0.825. So I have written it that the probability of subjects survival in after this year is 0.825. Okay, that's what I have written on the slide. For the second year, six individuals were lost in contact. Six individuals lost in contact. So it's the 33 mentioned right next to the subject over here. So I'm adding the formula 33 minus 0.5 into 6. Now where comes the 6 from? 6 are the lost number we have. These are the censored group I'm calculating. So the total number of individuals would be 3 divided by 30 would be providing me the probability of individual dying in the second year. This is that written over here as well on the slides to make you more comfortable. And the probability of surviving is again mentioned at 1 minus is this, and similarly I have calculated for the probability for the third year. Okay, now if I have calculated all these probabilities, now someone asked me what is the cumulative survival probability of the individuals for 3 years duration. During third year, what is the cumulative survival? Cumulative survival means let's multiply these values again. So 0.825 into zero point 0.9 into 0.822 is giving us a value like the individual who were remain alive during the whole course of follow-up. That is the question. That is the cumulative survival probability. So in order to calculate the cumulative survival probability, we are multiplying 0.825 with zero point 0.9 with 0.822, and we are getting a value which is 0.61. All right. I am holding on intentionally over here so that you can also practice this for your own good. Okay, so the probability of cumulative survival probability for the whole follow-up period would be calculated by multiplications. Okay, let's move on to the next slide. This is the story I have written over here, and I have mentioned over here. You can see the figures are a bit off page, but this is an intentional attempt so that you can calculate these values yourself as well. This is the practice session I have left for you. Okay, so these probabilities once calculated are helpful to draw the image shown to you on the first slide of survival analysis, and that picture is called as actuarial life survival time table, actuarial survival curve. Actuarial survival curve. This is actuarial survival curve analysis, and this actuarial survival curve analysis is a sort of drawing a curve line based on those informations. All right, so actuarial life table or curve could be drawn based on the same probability values, and we are going to discuss. That's the first part of my survival analysis lecture, which we have discussed earlier too, but I just want to give you a quick recap. Our Thank you very much for your time and attention. Now let's move to the next part of the lecture. So over here what we are discussing is the Kaplan Meier method, but before going into that, let's have a quick look on these two graphs, and this is pretty straightforward. Over here you can see a single curve line structure over here, so it's a simple curve. Over here you are saying such certain sort of steps, right? So these are the step formations we are observing over here. What is on x-axis? It is the survival probability, so it starts from 1 and it's the same as in actuarial life table, so it always be starting with the probability 1. Over here and over here both are the same, and for the number of years it's also the same ones. So it's just a stepwise fashions which we are going to observe in Kaplan Meier method. All right, so a quick recap about the previous thing. How actuarial life table was originated? It was the same style, 0 to 6 years. 40 are the number of breast cancer affected women, number of deaths 7. In the 1 year there was no loss or censoring information. and then we calculated their probability of dying 0.175, and the probability of surviving year is equal to 1, subtracting 1 minus 0.175 is equal to 0.825. This is the value we have for the cumulative survival. Okay, so for actuarial lifetime table, we are drawing the straight line which we just noticed in the previous slide by using this information of cumulative survival. For the next year, 33 breast cancer affected women were in the cohort. Number of deaths 3, lost contact 6, so 30. This is the percentage this is the probability we are getting, 0.1, 0.9. Then we are multiplying 0.825 with 0.9, and we are estimating 0.743 is the value, and this is the cumulative survival value we have noticed. So the probability of surviving in the first year was being calculated, and then it's further multiplied with 0.9. So this is the value we have noticed. And remember, in the next second last slide, I have calculated that 0.610. How I calculated 0.610? It's by the multiplication of all these 3 digits. So what are those digits? 0.825 into 0.9 into 0.82. So the cumulative survival for 3 years would be 0.61, based on a calculation of probability of surviving in year 1, which is 0.825, probability of surviving in the year 2nd, 0.900, then the probability of surviving in the 3rd year, which is 0.822. Okay, so this is the cumulative survival duration. So over here, which is being drawn, and then we are using the same data for drawing actual real life table, right? Let's move on to the next slide. Because we are focusing on Kaplan Meier survival, what is the Kaplan Meier method? So the method is actually what it means. The actuarial life table method does not require information on the exact time about the death and censoring occur, because it's a year-wise plan. We are just getting an information whether the patient is alive or dead. So what if we are retrieving an information based on the exact death point or exact alive status of an individual? So if we came to know that the individual died in January, or is dying in March, or is dying in May, so in that case we can draw a stepwise fashion over here. Okay, that stepwise fashion would be very important for us. But what if the exact times when the death occurs are known? Survival probabilities can be estimated immediately after each individual death without any need to aggregate the data into intervals for 1 year, right? That is a key. That is a key for Kaplan Meier method. So instead of a holistic approach for a duration based study of 1 year after the completion of 2 years, we are now focusing or relying on patients individual informations we are getting, and we are drawing this chart, this curve, based on steps or events happening during that course of a follow-up. Okay, so it won't be a straight line or a smooth curve, it would be a stepwise fashion. Let's look for it. So if we look in this graph, we see on y-axis survival probability, which starts from 1. Okay, and if we look on x-axis, it says years starting from 0 to 7. Okay, that makes me happy that it's a quite lengthy study duration, right? And then I assume that the number of patients are also written as 40, 33, 24, 7, 9, 4, 1 and 0, right? Okay, that means the individual's record has been interpreted in terms of the total number of individuals at the start of the study were 40. The probability of living is 100%, you could say, but now they remain alive. Then there is a step over here within the first step. Now this first step which was made is the death incidence reported. Then there is a second step, then there is another step. So if we calculate the number of deaths over here within 1 year, we are expecting that roughly we are expecting number of deaths would be 1, 2, 3, 4, 5, 6. So how I'm going to count them: 1, 2, 3, 4, 5, 6. So if I assume that from 0 to 1 on x-axis, the steps I have to take to reach 1 are 6 in number. Okay, so these 6 steps are the deaths which were happen at different time durations within 1 year. So Kaplan Meier survival curve is telling me a story that the number of deaths happen in 0 to 1 duration are 6. Okay, so similarly it goes a long way, but over here you could see certain crosses. Now these crosses are actually the indications that this data has been lost. Those are the number of individuals for which the information has been lost. So these crosses are those indicators, right? So if all the whole the group has died, this last point after 6 years to 7 years, if all the individuals died, the line should fall down to 0, but it doesn't direct downward. The last line, look at the last section, last side between 6 and 7. If you focus on the lines towards the end between 6 to 7 years duration, the line is not coming downwards, it is just running from 5th year to 7th year. A parallel argument is being made. इसका मतलब है 5 साल से 7 साल तक लोग जिंदा रह रहे हैं, यानी कि कुछ लोगों का सर्वाइवल अभी भी है। 40 के बाद लोगों का सर्वाइवल है या नहीं वो दिखा रहे हैं हमको, लेकिन 0 से पहले एक आदमी जो है उसका लॉस कॉन्टैक्ट हो गया। ठीक है, उसका लॉस इन कॉन्टैक्ट हुआ, तो अगर लॉस इन कॉन्टैक्ट हो गया है तो उसमें हम ये कह देंगे कि वो अब फॉलो अप नहीं हो रहा उसका। ठीक है, अगर सारे मर जाते तो ये लाइन नीचे आके गिर जाती एक वाई एक्सिस पे। ठीक है, दिस इज़ व्हाट आई एम ट्राइंग टू टेल यू ओवर हियर। Okay, this means that survival analysis and Kaplan-Meier method is more advantageous. So we can use the survival analysis for comparisons. The prime objective of the study is to compare survival experience of two different groups of patients, or we can study clinical trials of two different medicines on two groups of individuals, or we can use the diagnostic tests for two groups and study which one is more sensitive or specific, कि क्या रिजल्ट्स हमारे पास अच्छे आ रहे हैं इनके साथ सर्वाइवल से या नहीं। सो ये क्लिनिकल ट्रायल्स में ट्रीटमेंट्स के अंदर ज़्यादा यूज़ किया जाता है, एक बात। दूसरी बात ये कि हम पेशेंट्स में ये रिस्पॉन्स देखना चाहें कि किसका सर्वाइवल एक्सपीरियंस ज़्यादा है, कौन ज़्यादा बचता है। मतलब बीमारी तो सबको है, तो क्या डिजीज सेवेरिटी, क्या इंडिकेशंस हो सकते हैं। तो इसका मतलब है कि हमें जब भी सर्वाइवल एनालिसिस मिलेगा तो हम दो ग्रुप्स को कंपेयर कर रहे होंगे। ठीक है ना। सो अब तक वट एवर यू हैव स्टडीड सो फार इज बेसिकली two things: actuarial life table, in which you are drawing a single curve line based on cumulative survival probabilities, and Kaplan-Meier survival, where the incidents are reported based on steps. Then what additional thing you have learned so far? Additional thing you have learned is that it's a comparison. Survival analysis are always comparative. Now the comparison will be made between two groups. These may be the clinical trials, they may be the clinical features of two individuals. Over here, if you look closely, this is an example that the investigator collected the data regarding the stage of group 1 and group 2. Let's assume in group 1 individuals have some are suffering from certain conditions, and group 2 are also suffering from a particular ailment. Okay, so let's make that the group 1, now I am focusing on the image you have seeing over here. In the y-axis you are seeing survival probability, in x-axis you are seeing the years. So the number of patients in group 1 are mentioned as 19, 17, 11, 9, 5, 3, 0, 0. All right, and group 2 also contains certain values, but group 1 are the tumor individuals without lymph node involvement or metastasis. Group 1. Okay, group 2 individuals are those which in are those women who have been suffering from breast cancer along with the regional lymph node involvement or distant metastasis. Okay, so now we are building up a story. In this story, the total number of individuals were remain the 14 number, yani 19 plus 21, again 40. So at the start of the study, they remain similar to each other. All right. In the first year, there were certain deaths numbers reported. Group 1, individuals with only tumors, no lymph node involvement. And in group 2, lymph node tumor metastasis are being reported over here, right? So based on this data, we are saying that group 1, look at the number 11 has been written towards the end, right? 11 has been written towards the end. And we are noticing one more thing over here. Now these are the group individuals which are reported over here, that survival probability for group 1 is 0.5, or let's say it's 0.45 to be more critical, in contrast to the survival probability for group 2 is, let's say, 0.20. That means group 1 individuals have a longer survival duration, are more surviving chance as compared to group 2. Okay, so the number of patients surviving in group 1 are surviving for a longer duration of time. They are surviving over a long period. This is the information we are getting from this survival analysis. ये वो की पॉइंट है जिसको आपने समझना है, ठीक है? आपने इस एग्जाम्पल में क्या इन्फ्रेंस निकालना है? आपने इस एग्जाम्पल से ये इन्फ्रेंस निकाला है कि वो लोग जो कि ग्रुप 1 के हैं, ग्रुप 1 के जो लोग हैं, वो लोग ज़्यादा अरसा तक सर्वाइव कर रहे हैं, उनका सर्वाइवल प्रोबेबिलिटी ज़्यादा आ रहा है एज़ कम्पेयर टू ग्रुप 2। वो उनमें से ज़्यादा तादाद मर रही है, नंबर ऑफ़ इवेंट्स उनमें एक तो ज़्यादा हो रहे हैं, ठीक है? दूसरा, उनकी तादाद में ज़्यादा लोगों की जो तादाद है उनमें सर्वाइवल प्रोबेबिलिटी वाई एक्स पे देखो तो ग्रुप 2 का जो वैल्यू आपको मिल रहा है, ग्रुप 2 में जो आपको वैल्यूज़ मिल रही हैं वो कम है वाई एक्सिस के डाटा ग्रुप 1 से, ठीक है? तो इस इन्फ्रेंस से आपको ये पता चला कि वो ब्रेस्ट कैंसर अफेक्टेड वुमेन जो कि सिर्फ ट्यूमर से इन्वॉल्व हैं, जिनमें रीजनल लिम्फ नोड नहीं है, मेटास्टेसिस नहीं है, दे हैव ए लॉन्गर ओवरऑल सर्वाइवल, right? This is what we are getting right now. Okay, this could be tested in the next example as well from my side. So let's say you in the last slide, this is that the survival is a useful tool to measure the probability of occurrence of the event under study changes with the time. This is the key. The survival analysis is useful to measure the probability of occurrence of an event. Remember the last slide just shown you, A or B? Occurrence of an event under study changes with time. 4 साल तक A का फ़ायदा हो रहा था, अगले 4 साल में B advantageous हो गया overall survival में. That is what survival analysis have an advantage. So it may be summarized in terms of proportion still alive at a particular point in time. मगर जैसे आप ये कहते हैं ना कि अगर आप सर्वाइवल की जगह इंसिडेंस दे दें, प्रेवलेंस दे दें, तो अब ये वो बातें हो रही. But it's several limitations in that point. The proportions, no account is taken about death and censoring. We are unable to identify if we are just measuring the prevalence of anything. We are not measuring the deaths and censoring of an effect. तो इसलिए हमें सर्वाइवल एनालिसिस करना है. सो कंपैरिजन ऑफ द सर्वाइवल एनालिसिस एक्सपीरियंस बिटवीन ग्रुप्स ऑफ पीपल ओनली इफ द सेम फॉलो अप पीरियड इज यूज्ड. I have given you an example of India and Pakistan comparative study for breast cancer, and I have quoted you that if I have a survival duration of 5 years follow-up data, and in India they have published 3 years follow-up data, so I can compare my 3 years follow-up study with their 3 years follow-up study. So I should have a comparative analysis. But if they have 10-year follow-up study and I am working on 2 years follow-up study, so the comparison is not at all possible. Okay, so we should primarily focus on a similar follow-up studies. So it doesn't provide any indication in change in survival with follow-up time. Remember the last slide, change in follow-up survival with the follow-up time. Remember the effect of B, which was not very much good in the starting 4 years, but it improved for the next 5 years duration in the test case example. So thus all can be solved by calculating cumulative survival probabilities. Cumulative survival probabilities were discussed in the last lecture for consecutive follow-up interval. These probabilities can then be displayed graphically in survival curves. Now we are good with it, and towards the last I'm going to give you one quick recap. For example, that there are two terms we are going to see in the literature. One is overall survival and the other is disease-free survival. Both have their own merits and demerits, but as the name indicates, disease-free survival means that the patient died of any other reason else than the reason of your interest in which you are focusing on. For example, the 40 individuals started in day 1 affected with breast cancer. 10 of them died. Now, if the 10 of them died with breast cancer, that is your interest for cause specific survival. But if 9 of them were dying with breast, one is dying with any other malarial infection or other thing. So either you are going for overall survival or cause free survival. So these values, why the survival analysis is important, you are going to have a look on this lecture. Thank you very much for your time. And one additional note for this, the survival analysis are very much attractive both for not only for physicians, clinicians, but also for the insurance companies too, because based on this survival analysis they are going to value the insurance value, predict the insurance value for an individual. For example, the insurance value for a young lad would be बेस्ड ऑन दिस प्रिडिक्शन के ये बंदा इस इलाके में ये लोग कितने अरसे तक ज़िंदा रहते हैं, तो उस हिसाब से हम इनका सर्वाइवल एनालिसिस प्लॉट कर लेते हैं और फिर एक्टर की या एक्ट्रेस के लाइफ के लिए हम इंश्योर कर लेते हैं ना. ठीक है, तो अगर आप देखें या न्यूज़ चैनल्स वगैरह में तो बहुत सारे लोगों को आपको पता चलेगा कि जनाब फ़लाने फ़लाने की इंश्योरेंस इतने की है और इस बंदे की इंश्योरेंस इतने की कवर नहीं हुई. तो वो जो नहीं हुई कवर वो इसी वजह से नहीं हुई कि उन्होंने उस पॉपुलेशन का सर्वाइवल एनालिसिस बनाया और उन्होंने कहा कि बूढ़े जो हैं, अगर कोई अब जैसे अब पाकिस्तान के अगर बूढ़ों की बात की जाए तो मेजॉरिटी ऑफ अस और द लाइफ एक्सपेक्टेंसी एज़ पर पाकिस्तानी डेमोग्राफिक सर्वे डाटा शोज़ अराउंड के जी हमारे पास 70s में कम लोग होते हैं. तो if we came across an actor who is living as like for age of 75, without any disrespect to that class, we could say that the insurance companies won't be offering him a much what you can say return or premium for that life based on the survival analysis. The average number of individuals life in Pakistan is about 60s, तो ये 75 पे हैं, तो वी शुड हायर फॉर कि इनकी इंश्योरेंस किस रेंज में होनी चाहिए. तो उसके पीछे जो बैकग्राउंड डाटा होता है वो यही होता है सर्वाइवल एनालिसिस का, कि इनकी लाइफ कितनी रहेगी अगर ये पहले से किसी आइलमेंट का शिकार हैं, तो उस डाटा को हम कम्युलेटिव प्रोबेबिलिटी में बना लें. ठीक है, थैंक यू वेरी मच फॉर योर वैल्यू टाइम एंड अटेंशन and hope you always will be having a good read about it. Stay safe. Allah Hafiz. Assalamu alaikum.